Today's video will be on probability. So our learning goals for today, by the end of the lesson you'll be able to use the language of probability correctly, you'll be able to calculate simple probabilities and the complementary probability, and you'll be able to calculate the experimental probability. Okay, so we've got some key ideas here, which is just some key terms that you'll read a lot when you're doing probability questions. So the first one is an experiment or a trial. So this occurs a lot, you'll read this kind of language. So an experiment, oh, that's a bad underlining, or a trial, could be anything like flipping a coin, rolling a dice, or spinning a spinner. Anything like that is often referred to as the experiment or the trial. So the outcome is the possible result of the experiment. So for instance, if your experiment was rolling a dice, your outcome could be getting a 5 or getting a 3 or something like that. Or if your experiment was flipping a coin, your outcome could be getting heads or tails. So an event is either a single outcome, so we can have an event such as rolling a 3, or it can be a collection of outcomes, so for instance rolling a 3, a 4 or a 5. So the probability of an event is a number between 0 and 1, so it's going to be a decimal there, and it represents the chance that that event occurs. So for instance, if something was given a probability of 0, that means it's impossible, never going to happen, no chance, 0. On the other hand, if something was given a probability of 1, that means it's certain, guaranteed, 100% going to happen. And in between, obviously, we have those decimals. So right in the middle would be 0.5, and that represents a 50-50 chance. So for instance, if you flip a coin, you have a 50-50 chance of getting heads, so you'd give that a 0.5. So we actually have a formula here, which is very important for you to know, which we can use to calculate probabilities. So if all the outcomes are equally likely, so for instance, if you're rolling a dice, you're equally likely to get a 1 as you are to get a 2, a 3, a 4, a 5, or a 6. So they're all equally likely. So we can use this formula. So the probability, which we write as PR, brackets of the event. So for instance, rolling a 3 could be your event. So the probability of rolling a 3, so let's actually do an example here. So a probability, let's say a 3, is the number of outcomes where the event occurs. So how many outcomes are there on a dice where you get a 3? Well, there's only one, because there's only one side that has a 3 on it, over the total number of outcomes. So there's 6 possible outcomes, getting a 1, a 2, a 3, a 4, a 5, or a 6. So it'd be 1 over 6. And that's how we would write that out. So the probability of getting a 3 is 1 in 6. So probabilities are often written as fractions, just like that one there, 1 over 6, but you can also write them as decimals, or you can write them as percentages as well. So if you had a certain thing like 1 over 6, you can get your calculator if you wanted to work it out as a decimal, and you'd type in 1 divided by 6, and you'd get a reoccurring fraction which we would round, a reoccurring decimal which we would round, which is 1.6 reoccurring. And we could also write that as a percentage. All you have to do is multiply that by 100, and that's 16.6 reoccurring percent. So that would be your answer as a fraction here, as a decimal, or as a percentage. Okay, so a few more key terms. So sometimes we read this thing called a sample space. So a sample space is the set of possible outcomes of an experiment. So for instance, if you were to roll a dice, the sample space would be 1, 2, 3, 4, 5, or 6. So that would be all your possible outcomes, all your possible events. So the complement of some event, so for instance, if your event is E, the complement of that event is written with E and a little dash above it. So E is the event, and the complement is anything but that event, so the opposite. So for instance, if your event was rolling a 3, the complementary of rolling a 3 would be rolling a 1, a 2, a 4, a 5, or a 6. So all the other outcomes where that event doesn't occur. Okay, so for any event, either it or its complement will occur. So for instance, when you roll a die, you're either going to get the event, so you're going to get a 3, or you're going to get its complementary, everything else. There's no other option. Hopefully that clears that up a little bit. So there's also a few other terms that are part of the language of probability. So for instance, if we have the word at least, it means at least. So for example, at least a 3 means, 3, 4, 5, 6, 7, anything greater than a 3, or 3 and greater, I should say. At most, it means, at most. For example, if you had at most 7, it means, 7, 6, 5, 4, 3, 2, 1, anything a 7 or below. So at most, the 7 is going to be the highest. Or, for example, again, that means or. So, for example, rolling an even or a 5. If you say, well, what are the chances of rolling an even or a 5? That means what are the chances of rolling a 2, a 4, or a 6? They're the evens, and a 5 as well. And, for example, rolling an even and a prime. So, what numbers are even and primes? So that's only a 2. 2 is the only number that is an even number and a prime number as well. Okay, so let's have some worked examples and get all these terms, I should say, and everything, and have a go at them. So a 6-sided dice is rolled. Okay, state the sample space. Remember, the sample space is all the possible outcomes. So the possible outcomes are 1, 2, 3, 4, 5, 6. Find the probability of rolling a 2. Okay, so the probability of rolling of 2. So that's all the possible outcomes where the event occurs. So 1, there's only one instance of rolling a 2, that's this one here. Out of the total number of outcomes is 6, so 1 over 6. So what is the sample space of the event? Odd. So what is the sample space of rolling an odd number? So in your question, you won't have this part here that I'm putting in brackets. I've just written that there just to kind of show you what it means. So what is the sample space of the event of rolling an odd number? Well, the sample space would be 1, 3, 5. They're the only odd numbers, so that would be our sample space. Find the probability of an odd. Okay, so the probability of rolling an odd number. So the number of times when the event occurs, there's 3. So we could roll a 1, a 3, or a 5. So there's 3 times when that could occur over the total amount of outcomes, which is 6. And then we're actually going to simplify that fraction. You would work down the page, obviously, in your books. So nope, that's not 6. That should say 3, because we're going to divide both of them by 3. Simplify our fraction, so 1/3. So I've got 1/3 of the time would be rolling an odd. So state the sample space of the complement of rolling an odd number. So the complement is kind of like the opposite, the other options. So the other options are rolling an even number, so you could roll a 2, a 4, or a 6. And find the probability of, now if we look here it says odd, but then we've got our little dash there, which means the complement of rolling an odd, which is rolling a 2, a 4, or a 6. So there's 3 options there out of total 6 options. We're going to simplify our fraction 1/3, and that would be our answer there. Okay, so we've got some more key ideas, but these are about experimental probability. So experimental probability, or relative frequency, is calculated using the results of an experiment or survey. So our formula here, our experimental probability is the number of times the outcome occurs over the total number of trials in the experiment, and we can also call that our relative frequency. Okay, so the long run proportion is the experimental probability for a sufficiently large number of trials. So obviously a small number isn't going to work. We're going to have a suitable large number. And the expected number of occurrences is the probability multiplied by the number of trials. So we'll do some examples. Hopefully that will become clear. So for example, a box contains an unknown number of coloured balls. We don't know how many are in there. And a ball is drawn from the box and then replaced. So we'll draw one out, look at the colour, put it back in the box. The procedure is repeated 100 times. So that's probably a suitably large amount of times. If we did it once, not large enough, because we'd be biased, we'd think, oh, do it once, you pull out, a yellow ball, they must all be yellow. No, we have to do a few times so we can get some different results. So for instance, 100 times, that'll give us a pretty good idea. So the procedure is repeated 100 times, and the colour of the ball drawn is recorded each time. So they've probably tallied it down. 25 red balls were recorded. So find the experimental probability of selecting a red ball. Okay, so experimental probability is going to be, hang on, I'll write this down. Experimental probability. Okay, so the number of times it occurred, 25 over the total number of times 100. Going to simplify our fraction there, divide both of those by 25, 1/4. So our experimental probability of drawing a red ball is 1/4, so 1/4. So B, find the expected number of red balls if the box contained 500 balls in total. Okay, so we know if it contains 100 we've got 25 of them being red. So a quarter of the balls are going to be red based on our experimental probability. So we're going to do 1/4 times 500 to get our answer. So in your calculator, if you wanted to type that in, you would do 1 divided by 4, because that's what 1/4 means. So you do 1 divided by 4, obviously to get 0.25, and then you type in times 1 times 500, and that would give you your answer. So 125. So I'm sure a few of you, ooh, what happened then? I'm sure a few of you could do that in your head, but I'm just showing you the steps for future questions. Okay, so that's all we've got in today's video. Hopefully that makes some sense. We use a lot of probabilities in maths a lot of the time actually, so make sure if you have any questions you come and see me.